Okay, so this is the page. This is the reason we got calculators out. So on some of these problems, you're going to be required to plug something in. Okay, so this is why we have our calculators. And we are doing some application problems. So all of these problems, if we were to graph the information given, it would have that wave. It would go up, down, up, down, up, down, up, down. So the first problem is talking about the vibrations of music. Do any of you guys have like one of those fancy CD players where it has like the sound frequencies and it like as it plays it like shows you going, it goes up and down? So that's what it's talking about. Those sound frequencies or those like sound waves are actually sine and cosine graphs. Okay, so if we look at this, this is what the sound wave can be modeled by, is this equation right here. And the first thing they ask is just, what's the amplitude of this model? 0.5, right? 0.5.
Yeah.
Okay, so that is how far up the notes are going from the middle. 0.5 up, 0.5 down. Okay, the vibrations are going up and down 0.5. What is the period of this model? Not 2 pi over 3. 2 pi over 2 pi over b. So 2 pi divided by, and what's the b value? 660 pi.
Oh, word.
So divided by 660 pi. And the pi's cancel. And we have 2 over 660, and I can divide both of those by 2. And I get 1 over 330. Okay? I want you to look at the next problem and see if you can start it. So we're not going to see if we can get the whole answer. I just want you to see if you can start it. What do you think you need to do? Okay, so we're going to say 2 pi divided by pi over 6. So I have, sorry, let me zoom in. 2 pi divided by pi over 6. And how am I going to fix the way that's written right now? Keep it, change it, flip it. 2 pi times 6 over pi. The pi's cancel, and we get 12. Okay? So the period of the function is 12 of whatever the units are. They didn't tell us what the units should be. Okay? Now they want to know the location of the buoy when t equals 10. So this is the calculator problem. We are using the cosine button, which means that the mode of our calculator has to be correct. So what mode should our calculator be in? Radians, because we're typing in a pi over 6. So radians. All right, so I have -4 cos pi over 6 times 10. Oh, that's it. So I'm typing it in just like that. Whew. All right, we get -2.
Oh, wow.
So in the context of the problem, what does that mean for the buoy? Yeah, what does it mean by -2? Down 2, okay? So if the water could be at like sea level, right, there's a level there. Are we above that level or are we below that level? Below. So we're saying the waves have made the buoy go lower than it's at the lower end versus the higher end. Does that make sense? So you've got like where the water would be if it was like completely still. And this means that the buoy has gone 2 units. It could be 2 inches, 2 feet, 2 meters, 2 whatever below that number. Okay? Does that make sense? All right. So we're going to say 2 units below the water level. wherever the water would have been if it was still. 2 units below that. Okay. For number 3, we're going to talk through all the stuff that we know about this function. Okay? Are we listening? So, for this function, we have a rodeo, and the performer is spinning a lasso in a circle that's perpendicular to the ground. So you can picture that, right? You guys have seen that when they have the lasso and it's got like a circle, or like making a circle out of it, okay? The height of the knot from the ground is modeled by, so that means that as they are circling this around, the height of the knot is going up above the ground and then down, up and down, okay? So it's making a wave. The height is making a wave. And it says this time that the t value is measured in seconds, okay? So the h is the height of the knot above the ground, and the knot goes up and down as they're making that lasso into a circle, and the t value is in seconds. So what does the 3 in the front of the equation represent? The amplitude, right? So whatever's the middle, we go 3 up from the middle and we go 3 down from the middle. Does that make sense? Can you guys tell me what the middle is? 3.5. Okay? What does the 5 pi over 3 tell us? It's going to help us find the period, right? Okay. So if we look at the first question, it says, what is the highest point that you can reach by the knot? So where would we find the highest point on our graph? Yeah, so the highest point would not be at the midline, would it? No. But it would be the midline with the 3 added to it. So if the midline is at 3.5 and the amplitude is 3, then what's the highest point? 6.5. So that's 6.5. And I'm going to go ahead and write that I did the midline plus the amplitude. I just want to make sure I understand where I got that answer from. That doesn't say tamp, that says plus amp. So midline plus amplitude. How do I find the lowest point? Subtract it, right? So 3.5 minus 3.5. And that is the midline minus the amplitude. How do we find the period of this graph? 2 pi divided by b. And what's the b in this case? 5 pi thirds, okay? So what do I want to do to that to fix? Keep it, change it, flip it. And what happens with the pi's? The pi's cancel, and we get 6 over 5. So the period of the model is 6 over 5. Okay? According to the model, find the height of the knot after 25 seconds. So what are we going to type into our calculator? Cos 5 pi over 3 times 25 seconds, right? So instead of writing t, we're typing 25 seconds plus 3.5. 2. Okay? And that's 2 units off the ground, whatever the units are. 2 feet, 2 inches, probably 2 feet. 2 meters? Probably 2 feet. Maybe 2 meters. Yeah, meters makes a little more sense. Okay. I want you to go ahead and try number 4. Give number 4 your best shot. Alright, did we find the period of the graph? 12. So we did 2 pi divided by pi over 6, and when we fixed it, we got 12, right? Now, in the problem, they say that t represents what? Months. So what's the period of the graph? 12 months. It's a year. Okay? Does that make sense? So they are talking about the average temperature over the course of the year in that particular city or town or whatever it is. Centerville? Okay. So what does the period represent? 12 months. So the temperature for a whole year. All right, what is the maximum high temperature? What is it?
85.
85 degrees, the maximum high temperature. Now this is average, right?
Okay.
This is average high temperatures. Okay, so this would actually be like, stuff like this is like where I'm from in Oregon, this would be like an average high temperature. We don't have a lot of days in the 90s. It happens every so often because of global warming, like not typically. All right, when does the maximum occur? When does the maximum occur? Okay, so let's draw a little picture of a graph here, because we can figure this out. It's not too bad. So the beginning of the graph, and it begins at 0, it ends at 12. And what happens if it's a sine graph? It starts at 0, and what does it do? It goes up, and then it hits the middle, and it goes down, and it comes back. Okay? And this, I kind of drew it like it was 0, but technically our midline is 60, right? So it hits the top right here. If the whole thing is 12, then this right here would be what? 6. And this right here would be what? 3. So it's going to hit that maximum value at 3 months from the beginning of this problem. When did this problem begin? April 15th. So May 15th, June 15th, July 15th is when they hit their maximum average temperature. So we're going to say July 15th. Is that a reasonable answer if we're talking about a city in the United States?
Yeah.
July 15th maximum temperature? That kind of makes sense. All right. Go ahead and turn the page.
Are we doing?
All right. A Ferris wheel. Are we ready? A Ferris wheel at an amusement park has riders get on at position A, which is 3 meters above the ground. So our graph is going to start 3 meters above the ground. Okay? The riders go up, they reach their highest point, and they come back down again. What kind of graph does that look like? That's a coast graph. Okay? So when you're on a Ferris wheel, you start at A, you go higher, 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 you reach the top, and then you go down, 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 and you reach the bottom. Okay? So on the coast graph, you get on, you go higher, 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 reach the top, you go down, 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 reach the bottom again. Okay? Does that make sense? All right. So when we reach the top, how high off the ground are we?
23 meters.
We are 23 meters off the ground. Okay? What's the diameter of that Ferris wheel? 20. Yep. So you're 3 feet off the ground, then you're 23 feet, or sorry, meters. You're 3 meters off the ground, and then you're 23 meters off the ground. That means that the diameter, I'm going to go ahead and label that, the diameter of this particular Ferris wheel happens to be 20 meters. Okay. 23 minutes, 20 meters, sorry. All right, I got a lot of chatter, and the chatter's not helping. Okay, so let's stop with the chatter. All right, look at the problem. If we do 23 plus 3, and I divide it by 2, 23 plus 3 divided by 2, that gives me 13. What did I just find? Not the period, the midline. I found the middle of 23 and 3. When I added them together and divided by 2, I found the middle. Okay? So that means that my midline is right here at 13. Okay? Now I'm going to do 23 minus 3 divided by 2. And that gives me 10. And what did I find there? I found the amplitude. Okay? So this right here, the amplitude is 10. The amplitude is 10. Okay? All right. It says that the ride takes 40 seconds. When they tell us that the ride takes 40 seconds, what are they telling us?
That's where it's in.
It starts at 0 seconds and it ends at 40 seconds. They gave us the period. 40 seconds is the period of the graph. Okay. We are going to start writing this equation. What they wanted us to do is they wanted us to write an equation. So what type of equation are we writing?
Cosine.
Cosine. Y equals
10 cosine.
So 10, because the amplitude is 10, cosine. Is that 10 supposed to be positive or negative? Negative, because it's an upside down graph. It starts at the bottom. So that's a negative 10 cos. Okay. We need to have a number in front of the x, right? So how do we mathematically find a period of 40? How do we find the period?
It's 80.
It's not 80. What's the formula? 2 pi divided by b equals 40. 2 pi divided by b equals 40 seconds. We are trying to solve for b. We could cross multiply. Let's put 40 over 1, and then we can cross multiply. So I get b times 40 equals 2 pi times 1. And how do I get the b all by itself? Divide by 40. So b equals 2 pi over 40, which is pi over 20. Okay. So my b value is pi over 20. It's a weird looking answer, but they always look kind of weird on real life problems like this. Right? Like if you looked at the first page had that too. Remember the first one was like 660 pi. And then 5 pi thirds. Yeah. So we have to have a pi in our b value because the period of the graph doesn't have a pi in it. So there had to be a pi to cancel out. Okay? Yeah.
Like, where would you apply this? Like, in what,
So, this particular thing, I could see you applying it anytime you're talking about waves. So sound waves, heart rates, things like that. You can look at, if you write the equation first, then you can pinpoint specific values within that graph. So we're going to do that right now. We're going to write the equation, and then I'm going to say how far off the ground are you at 27 seconds, and we can figure it out. And it's plus 13. Where did Carrington get the plus 13 from? That's the midline. Okay, so what we're going to do now is we're going to take this equation and we're going to say, what is the height at 27 seconds? What is the height at 27 seconds? I can plug it in, right? And I'll be able to find the height. So this is where we're probably going to have to go to the state fair and get on the Ferris wheel so that we can figure out Are any of you guys going to the state fair? I might legitimately write an extra credit problem that you could do if you go to the state fair.
Are you for real?
Yeah. Because they have a Ferris wheel, right?
Yeah, but I'm a little scared of Ferris wheel. It's not very safe.
You're just gonna have to go and ask what the diameter is of the Ferris wheel. They should know. Somebody should know.
There is a measuring thing.
And how high off the ground it is. That's all you have to know.
We could do that.
And then you could time it You can time it and see how long it takes to make one rotation. I'll write an extra credit point. Alright, so what is the height at 27 seconds? Whoa, that's in the video. Awkward, sending it to your mom. Sending it to your mom. What time is it? 2016. 2016, Bailey said inappropriate words, and I'm sending it to her mom. Alright, so the height. How high are you off the ground after 27 seconds? You are 17.540 meters off the ground. So, are you on your way up or on your way back down?
On your way back down.
You're on your way back down because it's more than halfway through the
Yeah.
Right. Okay. All right. I need you guys to use number 7 to help you do problem 8. All right, Cameron? Number 7 to help you do problem 8.